Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
In the near future, expect AI engagements to become larger, more strategically significant, and more mission-critical, with a focus on long-term scalability. We will see artificial intelligence continue along the path to becoming the most transformative technology humanity has ever developed. Hello viewers, are you ready for another exciting AI news? Welcome back to your one-stop shop for artificial intelligence. We're back with the latest rumors and sometimes shocking happenings in the artificial intelligence universe. In this video, we will discuss the possibilities of having a human-level artificial intelligence by 2030. Before we begin, everyone who's new to our channel, hello, and welcome to Robot Future, where we fill you in on every thrilling discovery and mind-blowing insights in the world of robots, AI, and future technology. So consider subscribing and hitting the bell notification for a ton of exciting robot content coming your way. Now, without further ado, let's get into the video. Will there be human-level artificial intelligence by 2030? What should be the next step in bridging the artificial-natural intelligence gap? Scientists and professionals are divided on the solution. Yann LeCun, the chief AI scientist at Meta and a 2018 Turing Award recipient, is betting on self-supervised learning or machine learning models that can be taught without using human-label examples. LeCun has been thinking about self-supervised and unsupervised learning for years. As his studies in AI and neurology progressed, however, his vision focused on several intriguing notions and patterns. LeCun recently talked at a Meta event, formerly known as Facebook AI, about possible paths to human-level AI and the impact of AI breakthroughs. Deep learning's acknowledged drawbacks include the need for a large amount of training data, a lack of resilience, and the ability to cope with novel situations. Out of distribution, generalization, or edge case sensitivity are terms used to describe the latter. These are the kind of problems that humans and animals are taught to address from an early age. What are SSL world models? We learn most of these things without being explicitly educated, simply by observing and acting in the world. We create a world model and learn about gravity dimensions, physical qualities, causation, and other notions during the first few months. This method aids in the development of common sense and the correct prediction of what will occur in the world around us. We then put these essential building blocks together to create more complex knowledge. Current AI systems lack this common sense knowledge, which explains why they are data hungry, require label examples, and are exceedingly inflexible and sensitive to not widely distributed material. How can we enable machines to acquire world models only via observation and gather the enormous knowledge that infants accumulate solely through the word is the question LeCun aims to solve. What is self-supervised learning? According to LeCun, deep learning and artificial neural networks will play a crucial role in the future of AI. He advocates for self-supervised learning, a type of machine learning that eliminates the requirement for human input and guidance in neural network training. The most prominent branch of ML is supervised learning, in which models are trained using labeled instances. While supervised learning has proven to be highly effective in various applications, it has proven to be a bottleneck due to its need for annotation by an outside actor, namely humans. A large amount of human labor is required to begin labeling training examples in supervised ML models. Second, because they require outside assistance to annotate new training examples, supervised ML models cannot progress on their own. On the other hand, self-supervised ML models learn by monitoring the world, detecting patterns, making predictions, occasionally acting and intervening, and updating their knowledge based on how well their predictions match the results they observe in the environment. It works in the same way that a supervised learning system does for data annotation. Self-supervised learning is far more in tune with how humans and animals learn. We humans do a lot of supervised learning, but self-guided learning is where we get the majority of our fundamental skills and sensibility. Self-supervised learning is a widely sought-after goal in machine learning because only a tiny fraction of the data available is labeled. There are various applications for the capacity to train ML models on large volumes of unlabeled data. Researchers have also applied self-supervised learning to computer vision applications such as medical imaging. The approach is called contrastive learning in this case, and it entails training a neural network to build latent representations of unlabeled images. For example, the model is given numerous copies of a photo with variable variations throughout training, such as rotating cropping, zoom color modifications, and different viewpoints of the same object. Learning like humans. According to Lacan, scientists have recently experimented with pure self-supervised learning on computer vision issues, where the model must anticipate the hidden parts of a picture, or the next frame of a video in this case. Images are highly three-dimensional. A picture's pixels can be arranged in an almost infinite number of ways. Humans and animals are adept at anticipating what will occur in their surroundings, but they are not required to anticipate the world at the pixel level. To intuitively filter the solution space and narrow it down to a few feasible options, we use high-level abstractions and prior information. When you watch a video of a flying ball, you expect it to continue on its journey in the subsequent frames. And if there's a wall in front of it, you expect it to bounce back. You know this because you understand intuitive physics and how hard and soft bodies work. Similarly, you'd expect a person's facial features to change over time when chatting with you. Their mouth, eyes, and brows will move while they speak, and they may tilt or bob their heads slightly, but you don't expect their mouths and ears to change places unexpectedly. This is the case because you have high-level mental representations of faces and are familiar with the boundaries that restrict the human body. According to Lacan, self-supervised learning with these high-level abstractions will be crucial in developing solid world models required for human-level AI. A fundamental component of the strategy is the joint embedding of predictive architecture. JPA is being developed by Lacan. JPA models create high-level representations of dependencies between two data points, such as two video clips that play back-to-back. Regularized techniques capable of extracting high-level latent features from input and removing unneeded data replace contrastive learning in JPA. A perception module, for example, receives and analyzes sensory data from the outside environment, whereas an actor module transforms perceptions and predictions into actions. A short-term memory module keeps track of activities and perceptions and fills in knowledge gaps in the model. The intrinsic or hardwired costs of actions, as well as the task-specific value of future states, are determined by a cost module. In addition, there is a configurator module that modifies all other modules to the specific tasks that the AI system wants to perform. Because it focuses the model's limited attention and processing resources toward information relevant to its current functions and goals, the configurator is crucial. If you're playing or watching a basketball game, for example, your perception system will be focused on particular features and components of the world, such as the ball players, court limitations, and so on. As a result, your world model will try to anticipate hierarchical characteristics more relevant to the job, while eliminating extraneous data, such as spectator activities, item motions, and sounds outside the basketball court. The implications of human AI. The majority of debates about human-level AI center on machines that can replace natural intelligence and perform any task that a human can. Naturally, topics such as technological unemployment, singularity, runaway intelligence, and robot invasions come up in these discussions. The future of artificial general intelligence is a widely discussed topic among scientists. Will artificial intelligence exist without the desire to survive and reproduce, which has been the driving force behind natural intelligence's evolution? Is it necessary for AGI to be conscious? Will artificial intelligence have its ambitions and goals? Is it possible to create a brain without a physical casing in a vat? While scientists make gradual progress toward the long-awaited goal of creating thinking robots, these are some of the philosophical questions that remain unresolved. A more practical research field, however, is developing AI that is compatible with human intelligence. This, I feel, is the field of lacuna's potential. This is the kind of AI that won't be able to invent the next big thing or write a gripping novel on its own, but it will surely aid people in being more creative and productive, as well as finding solutions to complex problems. Lacan said he thought it was the amplification of human intelligence. The fact that every human could do more stuff, be more productive, more creative, spend more time on fulfilling activities, is the history of technological evolution. Meta isn't the only company working on creating a human-level artificial intelligence, since the monetary rewards of such a thing would be enormous. So what are your thoughts on the latest artificial intelligence news and rumors? Do you think they will be able to do this? And if they do, would this be a good or bad thing for humanity? Please share your thoughts with us in the comments below. I'd be interested to hear your thoughts on the subject. Thank you for watching this video, and don't forget to subscribe to our channel. Take care and see you around.